So if you look at page 147 in your workbook, we're at Trig lesson number 2, trigonometric ratios for angles from 0 degrees to 360 degrees. So with that, we're going to go back to grade 8 and Pythagorean theorem, remembering that a squared plus b squared equals c squared, where c is of course the hypotenuse. In trig instead, we're using x and y for a and b, and r being the radius instead of c for the hypotenuse. So point xy lies on our terminal arm of angle theta. So take a look at what they've indicated here, remembering of course that's as if this right here is point P being x and y. So let's take a look at class example number 1. So it says sketch the rotation angle in standard position and calculate the exact distance from the origin to the given point. So if we take a look at this, at -5, +12, we're looking at, again, approximately right up here. Oops. And so that is -5, 12. And that is on our terminal arm. So if that is our terminal arm, then that tells us that our angle theta is, remember, always going back to our initial arm, which is on the positive x-axis. So that's theta. However, what are we looking at, though, is we're looking at our right triangle being right there. So it's almost like looking at our reference angle. So in this particular case, then, if I redraw it just a little bit to the side here, then what do we know? Well, what is our y value? Our y value is going to be 12. What is our x value? -5 or 5. Because really when it comes down to it, when we're putting it into Pythagorean theorem, we know that it's going to be squared and end up as a positive value anyways. And r is going to be that length of the radius. Okay, and so hit pause and then go through that calculation of determining x squared plus y squared is equal to r squared, and to determine the length of r, because what we're looking for is an exact distance, therefore no decimals. That's because you're going to minimize the use of your calculators, guys. Okay, so hit pause and we'll come together for a solution. So in this particular case, we have -5 squared, that's our x, plus 12 squared, our y squared, is equal to r squared, or 25 plus 144 is 169. When we take the square root of both sides, we recognize then that r is equal to 13. So the distance, the exact distance from the origin to the given point then is 13 units. So let's try hitting pause again and completing part B. So let's take a look at that solution then. So our sketch has the point Q, -2, -6 in quadrant 3, and you can see that angle in standard position going all the way around. That's the reflex angle, reflex being greater than 180 degrees. And so when we substitute those values in to x squared plus y squared equals r squared, we end up with r squared being equal to 40. So r would be then the square root of 40, and that's where we need to simplify. Remember, simplifying radicals, we are looking for a perfect square that goes into 40, and so that's why we're looking at square root of 4 times the square root of 10, and so square root of 4, of course, being 2. So 2 root 10 is equal to r, and we're looking for that exact value. If you were to take square root of 40, put that into your calculator and give me a decimal, that's going to be a decimal approximation, because root 40 we recognize as an irrational number, that is non-repeating, non-terminating decimal. So if you were to give me a decimal, it's just an approximation, even if you can give me 8 decimal places. Okay, let's just turn the page and take a look. So again, going back to a reminder of our trig ratios, for any time we have a right triangle, we can use our trig ratios. So we know that sine of theta is, of course, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And you guys, of course, typically remember the acronym SOHCAHTOA. So, looking at example number 2, so write the primary trig ratios for angle theta in terms of x, y, and r. So, of course, if our angle theta is in standard position, then opposite is y, adjacent is x, and r is our hypotenuse. So, sine of theta then is opposite over hypotenuse, or also known as y over r. Cosine of theta, adjacent over hypotenuse, or x over r. Tangent of theta is going to be opposite over adjacent, or y over x. And so they indicate that you should memorize these formulas. Some students use a phrase like 7 yellow rabbits to remember. Sine of theta is equal to y over r. And that's kind of, it's up to you. Obviously, it's one of those things that you can memorize, and it's nice to have that at your fingertips. At the same time, drawing that out and quickly running through SOHCAHTOA, that will also do the trick too. So let's take a look at class example number 3. So it says a point 15, pardon me, the point 15.8 lies on the terminal arm of angle theta as shown. So calculate the value of r and hence determine the exact values of the primary trig ratios. So a few things. One, you can notice that this angle that they've created is pretty much a 45-degree angle. 15.8 is implied to be right here. However, I think we should be able to agree that that's not really a reasonable place, but it's their choice to draw it that way, and you'll definitely see ones drawn like that. If you're drawing it, I would strongly suggest that you draw it with a little bit more accuracy than that, and that will also help you to see whether or not your ratios and your solutions make sense. So if that is our point, that is 15.8. We can recognize that our x value is going to be 15 and our y value is going to be 8. So then, in order to find, anytime they're asking for your primary trig ratios, they're exactly looking for sine of theta, cosine of theta, tangent of theta. So right away we can do tangent of theta because we know tan of theta is going to be opposite over the adjacent. So I can say tan theta is opposite over adjacent, or y over x, which is then going to be 8 over 15. And that's an exact value as well. When we're looking at sine and cosine, we need our hypotenuse or our r value. So again, let's hit pause and calculate that r value. So So we can see then, hopefully you found when you substituted everything in, r squared was equal to 289, which is a perfect square. It nicely works out to the fact that r is equal to 17. And so then that is equivalent to our hypotenuse. So then we know that sine of theta is equal to y over r, or opposite over the hypotenuse, which is then 8 over 17. And cosine of theta is going to be adjacent over hypotenuse, or x over r, or 15 over 17. Great. So if we turn the page, there's a little investigation happening here. So investigating trig ratios for angles between 90 degrees and 360 degrees. So if we consider angle theta in standard position with the point P1 root 3 on the terminal arm, show that the value theta is 60 degrees. So there's a couple of ways that we can do that. We can figure out what r is first and then look at either sine or cosine, but essentially since we know point P is 1 root 3, then that also tells us that's our x value, which is 1, our y value, which is root 3, or also our adjacent and our opposite with respect to angle theta. So that's the same as tangent. So what we could say then, hey, is we can say that tangent of 60 degrees and determine what that is. And our calculator would give us an approximation of 1.732, on and on and on. But at the same time, if we know that tangent of 60 degrees is also equal to the opposite over the adjacent, or also y over x, we would have root 3 over 1, or simply root 3. And when we look at root 3 is also approximately 1.732, etc. So we can show then that the value of theta is in fact 60 degrees. So calculating the value of r, so again, just hit pause. So you guys should have calculated then that r is equal to 2, because root 3 squared means root 3 times root 3, or root 9, which is of course also 3. So x is then equal to 1, y is equal to root 3, and r is equal to 2. So sine of 60 degrees then is root 3 over 2. Cosine of 60 degrees, or x over r, is 1/2, and tangent of 60 degrees is root 3 over 1, or simply root 3. So if we scroll down a little bit, part 2, the rotation angle in part 1 is reflected in the y-axis, so complete the following. So the point Q, xy, has coordinates then, so if we're reflecting it, if you think back to what it was right here, point P was 1 root 3, so if we reflect that, then the only thing that's actually changing is our x value, so we're looking at -1, then root 3. So the reference angle is going to be what in this particular case? Well, if it's a reflection, this is where we were, then we can see that our reflection angle, or reference angle, sorry, is going to be 60 degrees. The rotation angle, if this is 60 degrees, our rotation angle is going to be 120 degrees. So if we look at sine of 120 degrees, y over r is going to be then root 3 over 2, because of course we know that the r value is going to be exactly the same. X over r is going to be now -1 over 2, and tangent of 120 degrees, y over x, then will be root 3 over -1, so therefore negative root 3. So take a moment, hit pause, and confirm those ratios on your calculator. So let's take a look at part 3, and in fact, hit pause and try to work through parts A, B, C, and D in part 3 on your own. and then come back to this. So taking a look, we've now got point R, which has coordinates -1 and -√3 because it's been reflected from part 1 in both the x and the y-axis. And so why is it -1 and -√3? Remember, we're now into quadrant 3. Quadrant 3 has -x as well as -y values. The reference angle is still 60 degrees, and thus the rotation angle, so right here what they're showing is theta, is going to be 240 degrees. Your reference angle, remember, is just right here, theta r, and that's going to be from your terminal arm to the x-axis. So it's sine of 240 degrees, opposite over hypotenuse, or y over r, -√3 over 2, and cosine of 240 degrees, x over r, or adjacent over hypotenuse, -1 over 2, tangent of 240 degrees, y over x, or -√3 over -1, therefore positive √3. So why is it that I'm not changing my r value to negative? Remember, anytime you're using Pythagorean theorem to find your r value is always going to be positive. So hopefully you've confirmed those, and that's worked out. Confirming those in your calculators, remember, with the radicals, you're going to be looking for decimal equivalents. So if you put in sine of 240 degrees into your calculator, making sure hopefully you're all in degree mode, otherwise you're probably already scratching your heads, and you put in -√3 divided by 2, you'll have a decimal approximation. But of course you know that -√3 over 2 is your exact ratio, and that's often what I will be looking for. So again, turn the page now to page 150, and please work on completing part 4. So let's take a look at part 4. So if you've gone through part 2 and 3, part 4 should be pretty straightforward. So again, once we reflect in the x-axis from part 1, we move into quadrant 4. What do we recognize about quadrant 4? We've got positive x and negative y values. So when we look at our original point P being +1 and positive √3, now that negative √3 happens in that y value. The reference angle is again relative to the positive x-axis, and that's 60 degrees. Rotation angle therefore is 300 degrees. So putting together your ratios, we have -√3 over 2 for sine of 300 degrees. Cosine of 300 degrees will be x over r. R is, of course, still 2, so that's 1/2. Tangent of 300 degrees is going to be y, which is -√3 over x, which is 1, so it's just -√3. So hopefully you've again confirmed those ratios on your calculator. The observations are really, really key right here. So the trig ratios for angles between 90 and 360 are either the trig ratios of the reference angle or the negative of the trig ratios of the reference angle. So if you take a look back going through parts 1, 2, 3, 4, all of them are exactly the same when we looked at your ratios of the reference angle and to the rotation angles. The ratios are just the same. It is only switching positives and negatives. None of the numbers are changing. So therefore it's just the sign that's changing. That depends on your quadrant and whether or not the x and the y are positive or negative. So this is actually a really, really key observation. Not sure what happened to that little policeman with the stop sign, because he would be pretty important to have right here. Let's take a look at that, determining the sign of a trig ratio. I'm just going to go back here for a second. Is that important? And a little highlighter. Okay, so determining the sign of a trig ratio. So in quadrant 1, draw the rotation angle and complete that table. And so going through quadrants 2 through 4. So quadrant 1, we know that sine of theta is always going to be y over r, cosine of theta is always going to be x over r, tangent of theta is always going to be y over x. And is that going to change for any of quadrants 2 through 4? No, that's going to be exactly the same. What is only going to change is, of course, the value of our x and our y. Does the r change? No, you know that, again, that hypotenuse or that radius will always be a positive value. So looking at quadrant 1, when x is positive, so in quadrant 1, remember, and it might be helpful for you to write in, positive x, positive y, so therefore, in this case, x over r, we've got positive x over positive r, therefore cosine ratio will always be positive. For tangent, we've got positive y over positive x, so your tangent ratio will always be positive. If we go over to quadrant 2, what are we looking at? We know that we're now looking at negative x's and positive y. So when we've got sine of theta being y over r, cosine of theta being x over r, tangent of theta being y over x, well, our y is going to be positive, our r is going to be positive, and so then the sine ratio will always be positive in quadrant 2. Cosine theta, well, x is now negative, and r is going to be positive, so then we're looking at negative. Tangent of theta, we've got positive y divided by or over negative x, so again the tangent ratio is going to be negative. So again, let's hit pause, and would you please complete these for quadrants 3 and 4. Okay, so just take a moment and compare your values with mine. Of course, one thing to highlight here, tangent of theta, and we saw that with part 3 earlier. Y being in quadrant 3, both the x and the y values are negative, so we've got negative over negative, so that's why the tangent or tan ratio is going to be positive. So take a moment and compare, and once you're done that, let's move on to the next page. So sine ratios then have positive values in where? So this is tough, well, tough for me scrolling up and down, but I think you're just looking back to the other page, so that might be easier for you. But sine ratios have positive values in quadrants 1 and quadrant 2. Cosine ratios have positive values in quadrant 1 and quadrant 4. Tangent ratios have positive values in quadrant 1 and quadrant 3. Sine ratios have negative values in quadrants 3 and 4. And cosine ratios have negative values in quadrants 2 and quadrants 3. And tangent ratios have negative values in quadrants 2 and quadrants 4. So I don't know about you, but this, to try to memorize all 6 of these statements, that's a lot. So the easiest thing to do is what we call the cast rule. So memorizing it, we call it the cast rule, or some people say add sugar to coffee. So cast being starting down here in quadrant 4. So these are, cast tells you what is going to be positive. So in quadrant 4, we have cosine ratio is positive. Quadrant 1, all ratios are positive. Quadrant 2, sine ratio is positive, and quadrant 3, tangent ratio is positive. So you often see people writing CAST. So these are all ratios being positive, sine, tangent, cosine. Or if you don't like the fact that the cast rule starts in quadrant 4 and goes counterclockwise, you want to start in quadrant 1, which kind of makes sense, then that's why people say I'll add sugar to coffee. Okay? So again, this one I would recommend memorizing. It's pretty easy and quick to do so, but could you get through it without memorizing it? Yeah, absolutely, because if you know what your x and y values are, and you know if they're positive or negative, substituting those into your ratios will automatically give you the positive or the negative values. Okay, so let's take a look at class example number 4. So determine without using technology whether the given trig ratios are positive or negative. So we don't actually need to know the exact values. They're not asking for that. They're only asking, are they positive or negative? So what is it that we need to do? Well, we just need to determine which quadrant we're in. So 340 degrees puts us in quadrant 4, so only cosine is positive. That means that sine ratio will be negative. If I go across to tangent, 227 degrees. 227 degrees is right here in quadrant 3, and you can see tangent ratio is positive, therefore tan of 227. If you put that into your calculator, and you can be checking these as you go along, that one's going to be positive. Well, sine of 88 degrees is going to be in quadrant 1, so it doesn't matter if it's sine, cosine, or tangent of 88 degrees, they will all be positive. Cosine of 235 will be in which quadrant? We're talking about quadrant 3, and it's only tangent that's positive, therefore cosine will be negative. 308 degrees, putting us in quadrant 4, and therefore cosine is positive. That's cosine. Tangent of 123 degrees in quadrant 2, where only sine ratios are positive, so then we know that this will be negative. So if you're not sure, go ahead and just confirm that using your calculators. Simply put in sine of 340 degrees. Okay? So this next section is just taking a look at recognizing what those reference angles are and making an equivalent. So knowing that if we have cosine of 260 degrees, well, the equivalent to cosine of 260 degrees, again, we sketch that out. Where's the reference angle going to be? So we're looking at, this is 270 degrees, so 260 degrees is going to be right about here. That is my angle theta. What is my reference angle? My reference angle is just this color. So this is our reference angle right here, and the reference angle, if that whole thing is 260 degrees, we're looking at a reference angle of 80 degrees. So cosine of 260 degrees will have the same ratio as cosine of 80 degrees. The only difference will be the sine. So again, we go back to our cast rule, and because we're now in quadrant 3, cosine is going to be negative right here. So cosine of 260 degrees, that means it's going to be the negative of cosine of 80 degrees. Okay, and again, put both of those into your calculator and you'll see that they have the same decimal equivalent. Okay, so take a moment, work through the questions in class example number 5, put this in pause, and we'll come back and compare. Okay, So if you take a look at my solutions working through class example number 5, I think what would be really good for some of you guys, especially right now as you're just trying to internalize and process all of it, is to sketch out those angles. Recognize which quadrants are they in. Write out cast so you can clearly see which quadrant has which ratio being positive, and therefore the other ones are going to be negative. Okay, so think it through. Again, check them on your calculator right now while you can. If you take a look at what they've got here for patterns in trig ratios, again, I personally wouldn't bother memorizing all of those. What are they talking about? 180 degrees minus x, 180 degrees plus x, or 360 degrees minus x, x being your reference angle. So those are kind of like the formulas I've referred to in class of the quick general rule as to how you can determine what the reference angles are. I would rather that you not sit and memorize them, because then you get confused which one you use when, as opposed to just conscientiously thinking about where that reference angle lies and doing that calculation for yourself. So I wouldn't bother memorizing these ones. Certainly look at them, but okay, we're done. So work through the assigned questions then, please. Thank you.